My intention is not to seek recognition, but rather to inspire others to contribute positively to their communities and families. I hope this message resonates within your networks, as I will be seeking assistance in realizing my vision. I have diligently laid the groundwork for this initiative, which marks the beginning of a brighter future. My objectives will only be achieved through a nationwide effort. I invite you to stay tuned for upcoming events that I will be organizing, which will include donation drives and other initiatives aimed at reinvesting in the very essence of our society, the youth. I eagerly anticipate garnering support from the community with which I have been fortunate to connect. I welcome volunteers for these events and encourage anyone with community connections to assist me in maximizing our impact. I express my heartfelt gratitude to you, Christopher. We are meant to navigate these challenges. Accepting or releasing them is not a sign of weakness or submission. Rather, we are meant to find empowerment in overcoming them. The soul becomes lighter, and our faith in ourselves grows. I sincerely appreciate your steadfast support during pivotal moments in my life. Reflecting on a difficult period 6 years ago, I acknowledge that while I am not entirely healed, I have made significant progress since then. I undertake these efforts out of love, with the aspiration of achieving harmonious alignment. It is easy to succumb to the darkness surrounding us. Confronting oneself is indeed a formidable task. However, I believe that anyone reading this has labored for a noble cause. All one needs to do is reflect the world one wishes to see, rather than the one that is projected upon them. If life is a stage, one is both the projector and the director. In a physical sense, I may identify as Cain. However, biblically, I am endowed with the capacity for redemption. I aspire to embody the qualities of the grape, yet my thoughts remain ensnared in complexity. Confronted with destiny, I experience trepidation, yet I maintain faith in the narratives I create. Secured in my solitude above the grave, I don garments of black. My journey is expansive, characterized by gratitude rather than entitlement. Grace dissipates the void within my vessel. My imperfections are inherent and not a reflection of my character. Thus, I urge others not to enable these defaults. I am but a humble creation, a breath of the divine, yet I do not claim angelic qualities. I acknowledge the messiness of my past. I emerge from the depths of adversity, transitioning from nobility to destitution, and ultimately to a life of compromise. Each scar I bear is a testament to beauty, and I liken them to cocoons from which butterflies will soon emerge. The intersections of thought within your consciousness reveal intricate coordinates. One may respectfully observe that, regardless of perspective, all experiences are acute and significant. It is a remarkable reality when one actively seeks truth, and those who have ventured into this realm would undoubtedly agree that even a single virtuous individual can outweigh numerous negative experiences. Thus, even if one possesses but a solitary positive quality, it serves as a unifying force. Let love be the essence of our praise and the foundation of our teachings. I do not presume to dictate the journey of another. Each individual's lessons are uniquely theirs. Nevertheless, we share a common path, pursuing the same destination. I am grateful for the roles individuals have played in my life, irrespective of the circumstances. Indeed, even the most challenging experiences, perhaps especially those, have profoundly shaped my perspective on resilience and the compassion I aspire to extend towards others. Blessed be, and may all who resonate with this sentiment affirm its truth. Ultimately, it transcends religious boundaries. It is about the collective essence we all share. In contemporary society, there exists a
Omega to Aquaris is a star system in the equatorial constellation of Aquarius. Its name is a Baird designation that is Latinized from Aquaris and abbreviated Omega to A or RAAQR. The system can be seen with the naked eye as a faint point of light, having an apparent visual magnitude of 4.49. The approximate distance to this star, 149 light-years 46 parsecs, is known from parallax measurements. 0 to 9 denotes temperature, with 0 being the hottest. I2V denotes the size of the star, and is found by calculating inherent luminosity. This is the Yerkes spectral classification. V corresponds to stars on the main sequence. The Johnson-Cron-Cousins, a very photometric system, is a common extension of Johnson's original system that provides redder passbands. The choice of colors on the blue end of the spectrum was assisted by the bias that photographic film has for those colors. It was introduced in the 1950s by American astronomers Harold Lester Johnson and William Wilson Morgan. A 13 in 313 telescope and the 82 in 2100 telescope at McDonald Observatory were used to define the system. The filters that Johnson and Morgan used were Corning 9800 and 63 and 3384 for V. The B filter used a combination of Corning 5030 and Schott GG13. The UV, the tometric system from ultraviolet blue visual, also called the Johnson system or Johnson-Morgan system, is a photometric system usually employed for classifying stars according to their colors. It was the first standardized photometric system. The apparent magnitudes of stars in the system are often used to determine the color indices BV and UB. The difference between the B and V magnitudes and the U and B magnitudes respectively. The system is defined using a set of color optical filters in combination with an MAA1P21 photon Polacher tube. The filters are selected so that the mean wavelengths of response functions, at which magnitudes are measured to mean precision, are 364 nanometers for U, 442 nanometers for B, 540 nanometers for V0. Points were calibrated in the BV-V and UBU- Butcher's indices, selecting such as zero-min sequence stars which are not affected by interstellar reddening. These stars correspond with a mean effective temperature TFK of between 9727 and 9990 Kelvin. The latter being stars with Class A AVV, meaning 5B. The system has a key limit drawback. The short wavelength cutoff, that is the shortest limit of the U filter, is set by any given terrestrial. For instance, a light echo is generated when a sudden flash from a nova is reflected off a cosmic dust cloud, resulting in the light arriving at the observer with a delay-compared trajectory. Owing to their geometrical configurations, light echoes can create the illusion of superluminous motion. A light echo is a physical phenomenon that occurs when light is reflected off surfaces that are distantly located from the source, arriving at the observer with a temporal delay corresponding to this distance. This phenomenon is analogous to an auditory echo. However, due to the significantly higher speed of light, it predominantly manifests over astronomical distances. A remarkably eruptive star has recently increased its brightness to 600,000 times its original intensity, temporarily outshining all other stars in the Milky Way galaxy, leaving astronomers both amazed and puzzled regarding the underlying mechanisms of this event. The light emitted by the star reflects off surrounding dust clouds, producing a striking light echo, as demonstrated in a series of new images captured by the Hubble Space Telescope. The echo is observed to expand over time as the light traverses outward to newly exposed layers of material, which is presumed to have been expelled into space during one or more previous eruptions of the star. the light reflects off the dust and is directed back toward Earth. The peculiar aspect of this event is that the star, designated V838 Monoc Eurotas, has expanded to such an extent that if it were positioned at the center of our solar system, it would encompass Jupiter. Interestingly, the star does not exhibit the hot and explosive characteristics typical of a supernova or nova, both of which expel outer layers in violent outbursts. Rather, V838 Mon, as it is referred to by astronomers, attained exceptional brightness while expanding to an enormous size and maintaining a relatively cool surface temperature. According to Howard Bond, a researcher at the Space Telescope Science Institute who lead the observations, a supernova would have been significantly brighter than V838 Mon, thus ruling out that possibility. V838 Mon exhibited brightness comparable to that of a typical nova, yet its behavior was markedly different. Bond elucidated that when an nova ejects its outer layers, a hot core is revealed. In contrast, V838 Mon did not undergo an explosive ejection on its outer envelope, thereby remaining cool throughout the event, which was observed from April to December 2002. In fact, it currently ranks among the coolest stars known, Bond remarked. The surface temperature of V838 Mon is approximately 3,600 degrees Fahrenheit 2,000 degrees Celsius, which is less than half that of the Sun's surface temperature. The observations are set to be detailed in the March 27th issue of the journal Nature. The images, which were publicly released today, have garnered significant attention from astronomers over the past 3 months. "These are truly astonishing images," commented Karen K. Witter, an astronomer from Williams College who was not involved in the study. "Initially, I found it difficult to believe. Astronomers are typically not accustomed to witnessing stellar changes on such a rapid timescale. Scientists remain uncertain about the timing and frequency of the star's previous eruptions, which have seemingly filled the surrounding space with dust. It is believed that this material is moving away from the star, albeit not at a velocity comparable to that of the recent burst of light that illuminates the dust and consistently overtakes new regions. I am a man on a mission dedicated to the process of reconstruction. My objective is to foster reconnection and ascension not solely in terms of elevated consciousness, but also in cultivating enhanced confidence and more sophisticated modes of thinking. Ground Up Hope Collective operates as an unprofit organization and a ministry, functioning as an independent entity. My aim transcends mere assistance. I aspire to cultivate a community. We represent the collective strength of the many. While the so-called false idols propagate deceptive promises that perpetuate the very issues that necessitate their existence, this endeavor does not entail the abolition of laws. Rather, it involves the re-establishment of our inherent rights and the redefinition of what it means to be at home and free. I invite you to join me in this journey. We have always constituted the majority, possessing an innate understanding of our potential. We have merely awaited the emergence of a leader bold enough to step forward. While I may not claim this confidence for myself, I hope to reflect the confidence within you. Let us embark on a path of healing together. In regard to the scientific discourse, we present photometric observations of SN 1993J in M81NGC 3031. Utilizing the Johnson-Cousins observatory system, our observations commenced shortly after the anticipated time of explosion and continued for a period of 120 days. The reddening along the line of sight to the supernova remains uncertain, with indications of both minor EBV tilde 0.08 mag and moderate EBV tilde 0.3 to mag values. For each reddening value, we corrected the observed fluxes for extinction and analyzed the evolution of the total optical flux, which accounts for approximately half of the supernova's total luminosity during the observational period. Additionally, we fitted the colors to a Planck function, allowing us to determine the temperature and total luminosity of the supernova for each reddening scenario. Notably, SN 1993J, classified as a peculiar type E supernova, gradually evolved spectroxyplation to exhibit characteristics akin to a type Ib supernova. We compared its bolometric evolution with that of the prototypical type IBS 1983N and found significant similarities between the two. Keywords astronomical photometry evolution development, interstellar extinction light curve, luminous intensity stellar temperature, supernova astronomical observatories, Casca in optics charge coupled devices, data reduction numerical analysis, optical filters reflecting telescopes, tables data astronomy supernova individuals 1993J. It is important to clarify that NASA does not monitor individual personal data in the manner one might presume. Instead, the James Webb Space Telescope and other observatories focus on the broader study of the universe, encompassing stars, galaxies, exoplanets, and more. The James Webb Space Telescope, launched by NASA, observes infrared light penetrate dense regions of space, thereby revealing details previously obscured to other telescopes. This capability assists scientists in addressing fundamental questions regarding astrophysics, including star formation and galaxy evolution. The UV-photometric system, conceived by Harold Lester Johnson and William Wilson Morgan in the 1950s, quantifies the brightness of celestial objects through the use of filters that capture specific wavelengths of light. Asterisk ultraviolet filter 364 nanometers Corning 9863 filter. Asterisk B blue filter 440 to nanometers of combination of Corning 5's Arrow 30 and Schott GG13 filters. Asterisk V visual filter 540 nanometers Corning 380 full filter. This system was calibrated using a zero main sequence stars with temperatures ranging from 9,727 to 9,790 Kelvin. However, it is important to note its limitations due to atmospheric interference affecting the U filter. The Johnson-Cousins observatory system serves as an extension, providing additional passbands. For instance, a light echo is generated when a sudden flash from a nova is reflected off a cosmic dust cloud, resulting in the light arriving at the observer with a delay compared to a direct trajectory. Owing to their geometrical configurations, light echoes can create the illusion of superluminous motion. A light echo is a physical phenomenon that occurs when light is reflected off surfaces that are distantly located from the source. arriving at the observer with a temporal delay corresponding to this distance. This phenomenon is analogous to an auditory echo. However, due to the significantly higher speed of light, it predominantly manifests over astronomical distances. The light emitted by the star reflects off surrounding dust clouds, producing a striking light echo, as demonstrated in a series of new images captured by the Hubble Space Telescope. The echo is observed to expand over time as the light traverses outward to newly exposed layers of material, which is presumed to have been expelled into space during one or more previous eruptions of the star. The light reflects off the dust and is directed back toward Earth. The peculiar aspect of this event is that the star, designated V838 Monoc Arotus, has expanded to such an extent that if it were positioned at the center of our solar system, it would encompass Jupiter. Interestingly, the star does not exhibit the hot and explosive characteristics typical of a supernova or nova, both of which expel outer layers in violent outbursts. Rather, V838 Mon, as this is referred to by astronomers, attained exceptional brightness while expanding to an enormous size and maintaining a relatively cool surface temperature. According to Howard Bond, a researcher at the Space Telescope Science Institute who led the observations, a supernova would have been significantly brighter than V838 Mon, thus ruling out that possibility. V838 Mon exhibited brightness comparable to that of a typical nova. Yes, its behavior was markedly different. Bond elucidated that when a nova ejects its outer layers, a hot core is revealed. In contrast, V838 Mon did not undergo an explosive ejection of its outer envelope, thereby remaining cool throughout the event, which was observed from April to December 2002. In fact, it currently ranks among the coolest stars known, Bond remarked. The visible structure surrounding V838 Mon expands from 4 to 7 light-years throughout the sequence. Bond stated that if the dust is expanding at a velocity of 223,700 miles per hour per second, then some of it may have been ejected into space approximately 20,000 years ago. We are still endeavoring to ascertain the detailed structure of the dust, which will require further observations as the echoes continue to evolve. He noted, thus, we are not yet certain whether there are multiple shells indicative of several outbursts. While the star has also been observed using ground-based telescopes, researchers remain uncertain regarding the nature of this celestial body. They suspect that the star may have expelled a relatively small portion of its outer shell into space before expanding and cooling. We do not yet comprehend the nature of the outburst or its causative factors, stated Sumner Starfield, an astronomer from Arizona State University, during a January interview at a meeting of the American Astronomical Society, where the images were previewed. In addition, Starfield and his colleague R. Mark Wagner from the University of Arizona, while observing the 838 Mon from the ground, discovered that it possesses a smaller, hotter companion star, given that the smaller star belongs to a common type. The researchers were able to use its brightness to estimate the distance to this binary system, which they approximated at 20,000 light-years or more. This implies that the presently observed outburst actually occurred 20,000 years ago. with the light from the developing Echo just now reaching Earth.